In this video, we are asked to optimize a multivariable function. And so, as always, the first thing that we need to do is determine what our objective function is. What exactly is it that we want to optimize? So if we look at the second last line, it says that we want to maximize total revenue. Well, immediately we know that revenue is equal to price times quantity. And so that is basically the framework for our objective function that we want to maximize. In this problem, however, we have two different products, the Powder Master and the Cliff Jumper, two different models of snowboard. And each one comes with its own demand function. And so what we have to do is to determine the maximum revenue. We need to determine the revenue. Total revenue is going to be the revenue from product 1 plus the revenue from product 2. And so that's going to be P1 Q1 plus P2 Q2. And so we know what Q1 and Q2 are. We just have to multiply Q1 by P1 and Q2 by P2. So let's start by looking at revenue 1. So revenue 1 is going to be P1 times Q1. So that's going to be 100,000 times P1 minus 140 P1 squared plus 10 P1 P2. So all I've done is taken Q1 and multiplied it by P1. And we end up with this. Revenue for product number 2, which is the Cliff Jumper, we do the same thing. So we have 200,000 P2 plus 40 P1 P2 minus 100 P2 squared. All right, and so once again, we have to add these two equations together to get our total revenue function. But I'm just going to keep them separated because it's going to be easier to work with them if we keep them a little bit separated. So we now want to find our derivatives. So we want to find the derivative of r. I want to find the derivative of r with respect to P1. And so the derivative of r with respect to P1, we have to take the derivative of both R1 and R2. Stop that. So the derivative of R1 is, with respect to P1, is 100,000 minus 280 P1 plus 10 P2. And then down here, we're simply going to have plus 40 P2. And that would be equal to 0. Well, we can combine these last two terms. So we have 100,000 minus 280 P1 plus 50 P2 equals 0. Well, now we want to find the derivative of r with respect to P2. So that's going to give us 10 P1 and 200,000 plus 40 P1 minus 200 P2. And we can combine these two terms So we end up with 200,000 and minus 200 P2 plus 50 P1 equals 0. So there's our two partial derivatives. We have one of them right here. That's with respect to P1, and this one right here with respect to P2. So the next step in the process is always to solve for P1 and P2. So I'm going to create a system of equations, and I'm going to make that equation look like 280 P1 minus 50 P2 equals 100,000. Keep my constants positive. And the second one will be minus 50 P1 plus 200 P2 is equal to 200,000. And now to solve this equation, it looks like the easiest thing to do is going to be to multiply the first equation through by 4, which will give us 1120 P1 minus 200 P2 equals 400,000. Don't have to do anything to the second equation. But now you can see the P2s will cancel out by elimination. And we should end up with 1070 P1 is equal to 600,000. Or P1 is equal to 600,000 divided by 1070, which comes out to 561 to the nearest integer. Well, only one more step to find out what P2 is. Let's go back to one of our equations. Let's take this one. It's as good as any. So we have a minus 50 P1 plus 200 P2 is equal to 200,000. And substituting in 561, negative 50 times 561 P1 plus 200 P2 is equal to 200,000. We end up with negative 28050 plus 200 P2 equals 200,000, or 200 P2 equals 228,050. And so then finally, P2 is going to be 228,50 divided by 200, which should come out to 1140. Okay, and once again, if they don't come out to integers, which they probably won't, make sure that you round to the nearest integer. I believe the directions ask you to do that. So we have our two answers, P2, which is right here, and we have P1 right here. All right, I hope you enjoyed this video.